Every product or service has a requirement, a description of what the customer needs. When a particular product meets that requirement, then it can be said to have achieved quality, provided that that specification accurately describes what the enterprise or the customer needs. Why do we strive for the best quality? Can we afford not to? Absolutely not. We're dealing with our customer's key component. It's the most critical part in any technology or any physical device that we have. And as a result, the consequences of getting that wrong or having a poorly produced PCB, a poorly specified design, are seriously too grave not to have the specification. When it comes down to quality work, in the PCB business, IPC has defined the global set of standards that fit across the global PCB community. They have provided the PCB industry with a common language that helps to align customer needs and expectations. NCAB Group has defined its own stronger product specification, the aim of which is to bridge the gap and cover some of the points that IPC does not. This is a list of over 100 key points that define our expectations for what is acceptable. And here you will see a number of examples that demonstrate our vision for quality.
When we turn on our electronic products, they heat up, and then when we power them down, they cool down. Inside, the printed circuit board does the same thing. It heats up, and then it cools down. This is the thermal cycling effect. Over time, thermal cycling of the printed circuit board during the normal use results in fatigue of the copper in the plated through hole. This fatigue results in cracks that will cause failure of the printed circuit board. The thicker the copper in the plated through hole, the longer the time that the printed circuit board will last before failure. It'll thermal cycle longer. This is why there are different thicknesses for the copper in the plated through hole according to the IPC class system. The tiers for IPC classes are Class 1, Class 2, and Class 3. Class 1 is consumer electronics. These would be products like our TV remote, products that have a service life expectation of only a few years. Class 2 products are continuous service products. Here we anticipate at least a 5-year service life. These products are computers, infrastructure telecommunication products, industrial controls, some automotive products, and some non-life support medical products. IPC Class 3 is reserved for military, aerospace, and life support medical. Here we're looking at life expectancy of the products in excess of 10 years. In the case of copper in the plated through hole, the IPC uses 2 different levels, one for Class 1 and 2 products, and a higher level for Class 3 products. For Class 1 and 2 products, the requirement is 20 microns of copper as an average and 18 microns in the thin spots. For Class 3, the requirement is 25 microns as an average and 20 microns in the thin spots. The NCAB specification requires that all boards are made to IPC Class 3, even Class 2 product. This improves the reliability of the plated through hole and provides a circuit board with a longer service life. We believe that the risk of not doing so can be very costly. A field failure is very expensive. And as technology continues to increase, this will become even more important.
The NCAB qualification and release process is a vital step in our PCB manufacturing, because if the PCB is not inspected and validated properly, this increases the risk that something is wrong, and the risk for serious problem occurs. And if this PCB is sent to the customer and they don't discover the problem, the PCB can be assembled and even put in the final product. And in worst case, we can have a PCB that needs to be recalled from the field. IPC standard doesn't give any details what should be reported, and they don't supply us with any documentation or templates which we should fill in for the release process. Not even for the high demanding PCB according to class 3, which is life supporting system and military system. They don't even have templates for these products. And for customers, it's very rarely that they also supply these documents. I think under my 26 years in the PCB business, I can remember like 2-3 cases where the customer have supplied detailed information what we should report. This is why we can see so much variation in what the factories support in form of outgoing report. It can be from very simple documentation to more complex documentation. NCAB have a specific inspection standard which the customer's demand should be inspected and validated towards. This template which we use includes a lot of features. There are items like the certification of compliance, the material used, the design parameters, hole and outline dimension, visual inspection, microsection, reliability test, solubility test, to mention a few. And the NCAB inspection document is a template which is in both Chinese and English, so it should be very clear both for the factory and for the customer the reported demands. NCAB factory management team have developed a very detailed PowerPoint presentation how to use our template, and we use this PowerPoint to train the factories on site regularly. Even with this level of training we're still using our QC inspectors to periodically checking the documentation which leave the factory to see that it is complete and valid. The final product is inspected towards this inspection standard and delivered with the first article report, including a microsection. This is the NCAB qualification and release process.
IPC have guidelines for circuit repairs and also says that the customer and supplier should agree if repairs are acceptable or not.
However, the experience I have is that this is rarely something that the customer and the supplier talk about. Poor repair can actually lead to open circuits being supplied, and even good repair has a risk of failure that can lead to potential field failures. For NCAB Group, it is to take responsibility, and the best part is that it is not cost-driven in the same way as other things, such as type of plugging or very thick copper. It's all about lack of knowledge, and many times it's also about customers' lack of experience of field failure and all effort and time and cost that occur when it happens. It's a nightmare that no one wants to live through. NCAB has a strict policy when it comes to this subject. We do not allow repair of open circuits and track welding, period. The more we teach our customers about how to build reliable boards and avoid traps, the more likely they are to put it in their own specification as a demand.
The PCB is covered with a coating, an ink, that is there to ensure that only the area we want to solder will be subject to solder and protect the circuitry on the board. IPC does not specify the thickness of the solder mask, but the thickness can affect the product's quality. Thin deposit of solder mask can lead to problems with adhesion to the ink to the surface, resistance to solvent and hardness, all which can see solder mask coming away from the board, and poor insulation characteristic due to the thin deposit can lead to short circuit through unwanted electrical continuity, arcing. That's why NCAB Group imposed this request about solder mask thickness. Soldering problem can also be caused by an excessive solder mask, as if too thick between component pad, then this can use component to sit not properly during assembly process. Sometimes factories can get thicker deposits than desired, And in my experience, I have seen an instance where the thickness was thick and the customer had only referenced IPC, and therefore, technically, it could have been argued that the thickness was fine, as no limit was defined. Even though it caused assembly issue for the customer. This is why having a defined range of solder mask thickness provides more security for our customers. The requirement to measure solder mask thickness should be as agreed between user and supplier. Noting that any agreements or demands outside of this should be covered in the procurement document. So if the customer does not specify thickness, then any thickness can be a good thickness, very thin or very thick, as long as it does not peel off and can withstand a certain voltage and a certain thickness. For NCAB, this is not good enough. With the proper thickness of the solder mask, the PCB will be better electrical insulation, less risk of flaking or loss adhesion, and greater resilience to mechanical impact. NCAB aims for a thickness between 10 and 30 micron, depending on the design, usage, and purpose of the PCB. The knee of the track should be greater or equal to 5 micron.
Wire filling comes into action when the customer has written wire hole plugging into PCB documentation. But in case they haven't specified which method should be used, as in standard wire plugging cases, NCAB follows IPC standard 4761 type 6B. This will be done as a separate process before solder mask and surface finish application. At the moment, IPC doesn't specify or give a requirement for the depth or amount of wire fill in standard solder mask ink plugging. Of course, the target for filling level inside hole is 100%, but our manufacturing experience tells us that there are tolerances within the processes. So our minimum target 70% of filling level is aimed to ensure optimum functionality and reliability on a repeatable level. There are several things which can go wrong and what we can avoid by doing properly wire filling. Here are some of the things which come to my mind. Well-filled wire hole can prevent any corrosive residues, either from PCB manufacturing process or from assembly, becoming trapped in plating through holes. Solder ball entrapment into hole and blowout can be prevented. During the life cycle of assembled board, no dust nor humidity can penetrate into filled wire holes, which surely gives long-term reliability. A good fill also prevents any problems with conformal coating, leaking through, or vacuum problems during in-circuit testing at the customer stage. To provide PCBs with reliable wire hole filling, NCAB recommends to customers and design houses to specify IPC 4761 type 6B. We believe that this topic is so important that we rise it up in every customer seminar and designer meeting. And to our delight, we have already seen design houses and companies updating their PCB specifications in line with our recommendations.
Our commitment to quality is not just helping to get it right first time or to ensure that we perform better than our competitors. It's helping us reduce waste. Poor quality has been measured in many ways over the years. What we are trying to do at NCAB is to try and quantify our environmental impact through improved quality. More reject products or more scrap means more energy being used to process boards, more remakes, more use of chemistry, more lighting, more electricity. So what we're trying to do is to reduce that. This is our list. This is our way of describing and delivering quality. It's a living document that's constantly under development, constantly being improved with input from all corners of the NCAB globe. It's an ongoing pursuit of excellence in all that we do.